3 is going to take us to the Pythagorean theorem. This is another one of those terms that people remember from school. Sometimes they don't remember the formula quite as well as slope-intercept, but it is one that they will remember from their school time. So the Pythagorean theorem is what we use for a right triangle, and we can use this in real life in many different situations. It says the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Now, I'm going to go ahead and I'm going to label the legs first. And so I'm going to label one leg as A and the other leg as B. Because this is a right triangle, you're going to go ahead and you're going to see that little square. That means the square fits in there nice and tightly. And that will tell you the legs of the triangle. The legs of the triangle are the two sides that create that right angle. Now the hypotenuse, that fun big word, so you got Pythagorean and you have hypotenuse. The hypotenuse is going to be that opposite side. And when I was learning it, the square there that's marked for the right triangle will point to your hypotenuse. And we refer to the hypotenuse as C. Now we get a formula that we will use for this that is called the Pythagorean theorem. And it says, what this says in words, I'm going to put now into an easy to use formula. The one leg A squared plus B squared, because it said it was going to be the sum, equals the square of the hypotenuse, which we now have called C. So A squared plus B squared equals C squared. That's the Pythagorean theorem. We're going to put it into use here in real life. And we're going to look at a bridge. And this bridge, the William H. Harsha Bridge, is a cable-stayed bridge. That means that cables run down and give it more support. And we want to know about how long this cable here that we've made red, how long that cable needs to be, the one on the very end. Now to know that, we better get some information from the picture. And I don't know if you can see that very clearly, but that's 212. So if I'm going to make a nice clear right triangle here, I have one leg that's 212 feet. I have this other leg down here, which would be the road, is 478 feet. And the red cable is making our hypotenuse that we do not know there. So we're going to go ahead and we're going to plug that into our A squared plus B squared equals C squared, which is our Pythagorean theorem. So I'm going to do 212 squared plus 478 squared, and that's going to equal my hypotenuse, which is going to be our C squared. Now if we put these into our calculators, because I don't expect you to know these just by heart, we would go ahead and 212 squared would be 44,944. 478 squared gives us a whopping 228,484, and that's going to equal our C squared. Now, we'll go ahead and we'll add those so we only have one term, and our one term is going to be 273,438. That's going to equal C squared. Now the problem is, it asked for the length of the hypotenuse, which is going to be our C term. So our C term there, and we have it as C squared. We only want to know what the length is, so we need to find the square root. If we are trying to find the square root there, we also need to find the square root here, similar to what we used to do with our balance equations. So now we have the square root of C squared would be C, which is what we want to know, the length of that cable, and the square root, and again you'd be using your calculator for this, the square root of 273,400, oops, I had a misprint there, that should be 428. Let me erase it because it is sloppy there. I just copied wrong from my calculator. 428. So that's on my display, my calculator. I'm going to do the square root of that, and the square root of that would come out to be 523. And I'll look back at my label, and that should be 523 feet. It came out with a decimal, but we're going to go ahead and just round it to the nearest whole number. You can put the wavy equals into it if you want to say that's an approximation. Now let's use that with a little bit easier numbers. And this time we're going to find the length, but this time we're going to find the length of a leg. Okay, again, let's go ahead and I would have my square corner here, making it a right triangle. So if you remember from the first screen, the legs are our A and our B, and the hypotenuse, which the symbol for the right triangle points to, would be my C term. So now I'm going to do a little algebra with this one. I have that my A squared is going to be 10 squared plus my B, and I don't know that one, so I'm going to leave B in there as my term, equals my C squared, and I know my C term is 12 squared. Now, these are the ones that I said you should probably memorize. Up to 13 is usually suggested. 10 squared, 10 times 10 is 100. That's an easy one. Can't do anything with B squared yet. And 12 squared, that might be a new one, but that's 144. Now again, I want to find my term B, so let's get the numbers together. I'm going to subtract 100, balanced equation because the equal sign's between there. I get just my variable term, B squared, and over here I get 44. Now again, I don't want to know the square of the term, I want to know just what B equals. So I'm going to do a different color so you can see this. I'm going to find the square root of B squared and the square root of 44. The square root of B squared is easy, B. And the square root of 44, I can't get a perfect square though, so I'm going to go ahead and I'm going to say, well, 44 equals 4 times 11 is the same as 44. And the perfect square of 4 would be 2. So that missing side is 2 times the square root of 11. And we didn't have any measuring labels there, so we could just say units. And using the formula just a slightly different way is called the converse of the Pythagorean theorem. And it's kind of an if-then. So if the triangle is a right triangle, then we said A squared plus B squared equals C squared. So I'm going to do just a little bit different and say then. So if, when we're saying it this time, so if I see something that A squared plus B squared equals C squared, I know that that's representing a triangle that is, in fact, a right triangle. So let's see how this works. The converse. So we're looking at if we just have terms and no picture, we want to know, is the triangle right triangle? If the measurements fit into this and make a true statement, it truly is a right triangle. So here they give me my 3 different measurements. So we're going to use our Pythagorean theorem again. I'll put it here one more time. This is a pretty easy one to remember. And they don't represent anything but those variables. So we're going to say 3 squared plus 5 squared. Does that equal 7 squared? 3 squared, 3 times 3 is 9, plus 5 times 5 is 25. Does that equal 7 times 7, 49? And in that case, we get 34. So these measurements will not make a right triangle. So this is not a right triangle. Let's go ahead and test some other measurements. We have 15, 8, and 17. So let's try 15 squared plus 8 squared equals 17 squared. Now I know mentally, I know my 8 squared is 64. I might need to use my calculator for 15 squared, or use your books. You can turn to the page we mentioned that has the whole chart on it. 225. And 17 squared happens to be 289. When I add 225 and does, in fact, equal 289. So the measurements of 15 and 8 and 17 do create a right triangle. This one would make